Hey, sorry I could not be here yesterday for your lab. Hey, it's me. Or today as you're working on it. But the goal today is to get your paper done in a way that you really understand it well. So, yesterday in the lab, hopefully Mr. Mull, Mr. Bowdy, Mr. Bennett, one or more of them were in there to kind of help you out. But you did the same reaction 6 times. It was a variation on a baking soda and vinegar volcano. The idea there, an acid and sodium bicarbonate bubbles up. And based upon how big our balloons got, we could tell how much product or how much stuff we made. So I'm going to click around and show you a couple different things. Right here, and I'll make myself a little bit smaller on this guy. This is a very simple simulation of making a grilled cheese sandwich. So I have to have bread and I have to have cheese. So the more bread I put in, the more sandwiches I could make, but I have to have enough cheese to be able to make those sandwiches as well. The more cheese I put in, the more sandwiches I could make, but I have to have bread as well. So the idea here is we have to put in both of our chemicals in the right ratio, or both of our ingredients in the right ratio, to be able to have a reaction go the way that we want. So what you did was you kept kind of, let's say, the same amount of cheese the whole time, but each time you started with different amounts of bread. You blew up the balloon a little bit more, a little bit more, and that's based upon how much of the other thing I made. Eventually, we would have ran out of one or the other, and that's true for every chemical reaction. This idea of bread and cheese making grilled cheese sandwiches is exactly what limiting and excess, or reactants, products, and leftovers is all about. It's just a little bit harder in terms of stoichiometry, or the reaction, the recipe isn't quite as obvious. So when I go here, we've got your paper. Hopefully, you were able to follow the procedure, make some predictions, and see your results here. This is a good set of results. Yours may not have looked exactly like this, but you definitely should have seen small, little bit bigger, little bit bigger. And then what makes it a little tricky here is as we go across the end, they stay about the same in size, but sometimes they're slightly different in shape. But those should have been about the same size. And then across the bottom, we zoomed in here was clear, clear, clear. There isn't any powder, but we do have powder in these last few, and we can see it there as well. The other thing that you would have done on part two is, well, what happens if I add a little bit of extra chemical? Just like, well, what if I got another piece of bread or another piece of cheese? Sometimes, if you already have extra or leftover cheese, more cheese doesn't help. If you already have too much bread, you don't need more bread. And that's the idea of what bubbled or what didn't when we added a little bit more. So part one was it getting better, bigger, but then staying the same. Part two was sometimes putting more stuff in bubbled, sometimes it didn't. So what we were supposed to do here is think about, based upon what we saw, how big the balloon was, how much it bubbled, how much solid was left at the bottom, and what happened if I added a little bit more. Think about the limiting and the excess, or another way we can say that is the thing that ran over and the leftover. So right here, we've got answers. This is posted for you, so you don't need to read exactly what they are. But limiting reactant is the substance that runs out first. It's the thing that determines how many grilled cheese sandwiches we can make. The excess reactant is your extra leftover ingredients. There's the ones that are just sitting there that maybe you can use the next time. So hopefully what we observed was initially we ran out of solid. There was a very small amount of solid. The When you put in more solid, it made the balloon bigger. Put in more solid, it made the balloon bigger. Put in more solid, it made the balloon bigger. But at a certain point, more and more solid didn't do that anymore. But then it stayed the same size because we ran out, or the thing that we had left over was the sulfuric acid, the liquid, our aqueous liquid. It couldn't get any bigger, even more though we put more solid in there, because I didn't have enough of the other thing. That would be like, well, I ran out of cheese. It doesn't matter how much more bread I have right there. When I added more baking soda to my first few flasks, it did bubble more because I needed more of that, but more acid didn't. Over here, more acid bubbled more, but more baking soda shouldn't have. So then what we're trying to do with our calculations is just think about how much stuff did we put in. So this is a simple one-step train track, grams to moles. There's no mole ratio. It's just add up the molar mass of sodium bicarbonate, grams to moles, grams to moles. You've got two different answers here. One is bigger than the other because in flask one, we put a tiny bit of solid. Here we put more. Here, we've got molarity and volume. We just make sure we have the right equations. Molarity is moles over liters. Let's solve for our moles. It's the same for all of them. Right here, we're writing out our balanced equation. The key parts that are important are reactant number 1, reactant number 2, and then the product that we observed was the carbon dioxide. In number 6, this is basically where we're putting our cheese and our bread together and seeing what sandwiches we could make. So what you're going to do, this row of this table is totally independent of everything else. So if you take those 0.05 grams or the moles of that baking soda, how many grams of CO2 should that have made? Grams, moles, moles, grams. We've got a set of tracks and we get an answer. So that's like, oh, if I had 4 pieces of cheese, I can make 4 sandwiches. Down here, we do the same idea, but we use our moles that we just found. Moles, moles, grams, same idea. If I use all of my bread, how much can I make? Moles, moles, that, so we get an answer. The theoretical mass, it says based upon which one ran out first, because we can't make both of these amounts at the same time. Something ran out and the reaction stopped there. So when you have 2 answers like this, the smaller answer is our right answer. So that's what we'll put right there. And the limiting and excess, we can go back to the previous thing we already answered, or we could acknowledge the reactant that gave me the smaller amount was limiting, the reactant that gave me the larger amount was excess. You do the exact same thing here on number 6, but it might have looked a little bit different or backwards in terms of how much we were made. Right here, calculate how many grams of sodium bicarbonate are needed to do this. We are going to think, if I start with my moles of sulfuric acid, moles to grams, but this time end with grams of sodium bicarbonate. So all of this is just over and over and over train tracks. Other than the molarity equation on this one, everything is train tracks. We just do a couple per problem. And that may seem like a lot of work, but what it's doing is saying, well, if I have this much of this ingredient and this much of this ingredient, how much stuff can I really make? The last question here, and I will show really briefly the answers, although you have access to them as well, is, okay, I needed a certain amount, but I actually put in a full 3 grams. How much was left over? So here I said our grams to moles, we've got that. Our molarity equation, our balanced equation. And like I said, it's just train tracks answer, train tracks answer. The smaller one's the answer. The thing that gave me the smaller one's limiting, the thing that gave me the bigger one's excess. Train tracks answer. Different set of answers here because a different chemical ran out. I put in new amounts so I can make a different amount. We need to double or triple our batch. We still want more of that chemical. Here, if all of my acid I wanted it to react, I'm ending differently. I'm ending how much solid would I need? Well, here I have the amount of solid. And then down here, sorry, we've got some extra practice problems. Those aren't on the worksheet, but if you wanted to kind of look through them and get some practice, it definitely won't hurt. Most of this week is just practice and repetition on this. And the key is to come back to this really simple idea here, that if I put in more hydrogen, if I put in more oxygen, I can make water, but I might have leftover of one thing or leftover of another. So whether I'm thinking about grilled cheese, a chemical reaction, it's the same idea. What's the recipe? But we take the amount of each thing, how much can it make? How much can the other make? And then what are we left with, or what is left over? So hopefully I'll be available for help throughout the week via Canvas and email. and maybe back before the end of the week. So take care, but work on this, do the Canvas assignment, ask questions, and help one another.